The title of this paper is Using Multilinear Feature Space to Accelerate CNN Classification. Well, this method reduces the time of classification of dense models, CNN dense models, but is not an architecture reduction method. Let's start which presents two examples of dense architecture. The first, called AlexNet. On the original paper, the authors related the necessity of using two GPU units to accelerate the training process and run. As we can see, this model is deep with very convolutional and fully connected layers. The second dense model is the VGG. This work showed the importance of depth of VGG models to solve complex problems with very big number of classes and samples. The VGG model is the basis of our study. Well, to solve the problem of dense architectures, some architecture reduction techniques are present. The work of Ruan et al. Its approach based on low-rank decomposition to prune a dense model. Well, the famous other famous work that is architecture reduction technique is Wilton. The work of Wilton uses the activation output of the last layer as class label and train a reduction CNN architecture with the original training samples, which is reduction model well now represents a framework overview of your method. Well, let's start with a trained CNN dense model. The traditional optimization techniques use some techniques to reduce this architecture complexity and obtain the optimized CNN model. And so this reduction method model is used to make predictions. Your approach work in another way. The victory maps of the dense CNN model of the dense trained CNN model is extracted and the feature space is determined and generate the metrics of agent vectors and main vectors for each layers of the model. And these pairs of agent vectors matrix and main vectors are used to make prediction, to substitute the dense layers on the original model. Well, this figure shows the flow of the proposed framework and the VGG classification process versus the proposed method. The method accelerates the classification approximately now. We have a detailed flow of the proposed framework. First, on the phase one, um, first, in the phase one, the training subset samples are converted to grayscale and resized to size of input of the VGG model. On the phase two, the VGG model is trained with this pre-processed subset. After training on the phase three, M and images of the trained subset are presented to trained VGG model, and for the layer L, M times K maps are generated, and the main vector X is extracted, and using PCA technique, the engine vectors are extracted, computed, and arranged in matrix A. Well, the phase 4 consists of apply the phase 3 for all layers of the model. Okay. We use the matrices of agent vectors and the main vectors to project the image samples on the layered space. With these low dimension samples, we train a weak classifier for substitute the fully connected layers. After our process, the matrices of agent values, agent vectors, and the main vectors, and the weak classifier substitute the complete VGG model. Well, on the experimental results, we use two ADAS database. The first database is the vehicle image database, and which this problem is with two classes. Consists of presence or not vehicles. Well, the second database is the Sherman Traffic Sync Detection Benchmark. And this database contain images of road traffic signal of various types. Well, um, before I present the results, uh, we present the acceleration metric, where it's the simple relation between classification time of VGG model and the proposed method. Well, uh, the best result widget in database 1 and 2 can see on the screen, where the best weak classifier used is based on multi-layer perceptron network for database 1, and this classifier show a minimal loss of accuracy and high speed up rate. For the database 2, the weak classifier based on multi-layer perceptron reached the best result, with the minimal loss of accuracy and high speed up rate. Well, the limitations of our method that we observe during the test phase, it's not feasible with many classes and samples because this method is memory expensive, memory consumption, which the high number of classes and samples demanding memory. The method show the low performance when images have a large variance of resolution and quality. It's for all. It's all.